Today we will learn the concept of potential difference from the second module of electromagnetic waves. So to define potential difference, what is potential difference? So a potential and potential difference are very important terms in the electronics and communication field. So here the potential difference and the potential will going to exist once there is an electric field. So there is supposed to be an electric field to have the potential difference. The potential difference will be the potential difference is to be defined as the work done on unit charge for moving it from a point, one point to the another point, which is called as the potential difference. If I consider for a space and we have got an electric field under two different points A and B, how much amount of force has been applied to move the charge q from the point B to A. So that amount of force applied, and here the work done in moving the charge from point B to point A, so called as the potential difference. Now the potential difference which will going to be written as the work done per the unit charge. So what is the potential difference? So difference between the 2 points A and B. So VA minus VB, so which is equal to the work done, which is labeled as W upon the Q. So what is that VA minus VB? VA minus VB can be rewritten as dV, that will going to be the differential in a potential, and the work done, small work done, that is dW by Q. So unit charge, so dV is equal to dW by Q, and we know the expression of the force. So force is equal to charge into the electric field. Here the electric field is a vector quantity, and the dV, so potential, is a scalar quantity. So the what is the unit for this potential difference? So potential difference will going to be the, for work it is the joules, and for the charge it is coulomb, joules per coulomb. So joules per coulomb can be called as the volt. So unit of potential difference is volt. So V is equal to, in other words, this can be rewritten as V is equal to W by Q, and the work done is going to be rewritten as W is equal to Q into V. So here for the potential difference, we need to remember that for the potential difference there is supposed to be electric field, and how much amount of work has been done for carrying a charge q for carrying a charge q. So that will be going to be the potential difference. So to define once again, the potential of a point A with respect to the point B is defined as the work done on moving a unit positive point charge from point B to A against the electric field. So this is the basic definition and expressions for the potential difference. Now we are already familiar with the electric field. Now what is the relation between this electric field and this electric potential? So how do we relate these two with another parameter called the distance? With a parameter distance, we can relate these three terms, that is the electric field, the electric potential, and the distance. Now in the, you can look into the diagram. So consider the electric field E. So electric field E is exists because of the point charge plus Q, and at point O in radially outward direction shown below. So in the diagram you can see the electric field is outwards, and from the point charge Q from the at a point O, and we are considering a two different points R and S. So the point R is at a distance of a small r from the origin, that is O, and the S is at a distance of a small distance, that is dl or dr. In some of the books they have referred it as dl, and even that can be called as the dr. So drr or dl is that small distance between r and s. So the distance between the O to S is r plus dr. Now the two different points S and R are the 2 points at a distance R and R plus dr from the point O, and this dr, the small, very small distance, that dr is a very small distance, and the change in that potential between R and S is very small. V is electric potential at point R and V is the potential at the point R. And now the here we need to remember that the electric field is outwards and we are applying the force in the opposite direction. So E and the force applied is in the opposite direction, that is the distance displacement dl in the towards O, and E is outwards. So hence the angle between these two is 180 degree and the cos 180 degree is -1. So that has to be, we need to remember. And now the force applied on the test charge Q to move from R to O is given by F is equal to Q into E. That is the basic expression we have. The force on the charge Q is equal to Q into E. So now what is the potential difference? Potential difference between the 2 points, that is, now here the 2 different points are S and R. Now here in general we have written it as VA and VB are the 2 different points. So potential difference is given by the work done in moving from B to A, or here it is S to S, WAB upon Q, and the potential difference is equal to force into displacement per charge. So this is the another expression, that is force into displacement per charge. What is the force? Expression for the force is uh, expression for the force is Q into E. So now we need to replace for the force. So force Q into E, and displacement is the small distance, that is a dl or dr, the small distance upon Q. And here y minus 1 because of the cos theta. Force into potential difference is equal to force into displacement into cos theta upon Q. Why cos theta? Because the directions may not be in the completely opposite. It may be oriented, or the theta can vary. That is why we are considering, when we are applying the displacement, that can vary. So that's why we are applying the theta value angle, that is cos theta. So now here the theta is 180 degree, cos 180 degree is -1. So force into dl -1 upon Q. So here this can be rewritten as minus Q into electric field into dl upon Q. So here the Q will get cancelled. We are left out with the E into dl. So what is E into dl? E into dl is the potential difference. The negative sign indicates that the opposite direction. So potential is decreasing. So dV is equal to minus E into dl, and electric field E is equal to dV upon dl, or it can be rewritten as minus dV upon dr. So potential is decreasing, that is why the term, that is why the sign negative. So this is the relation between. So now we are related, dV is the potential difference, E is the electric field, and dr is the small distance. So with the element of small distance we have related E and dV. So the expression or the relation between the electric field and electric potential. So moving on to the, what is the potential difference related to the source charge? It is the potential difference related to a source charge. That means there is a charge. So when we look into the diagram, so there is a point Q, and at the point Q is generating a charge Q, and this point Q is at a distance of A and B. We are considered the 2 different points A and B, and A is at a distance of RA. What is RA? RA is the distance from the point Q, the point O to A, and RB is the distance from origin point, the point O to RB. So RA and RB are the distances from O to A and O to B respectively. And next we have considered another point P, which is at a distance of X. And when you are moving the test charge from P to a small distance, what is that small distance? That small distance is dx. And now the dx is against, that is dx is moving towards O, and the electric field is outwards. So they are completely, the opposite, which means theta value is 180 degree. So that is what we have represented here. So consider a source charge q which is at a distance RA from point A and at a distance RB from point B. The electric field exists because of the charge. So charge is present and the electric field will going to exist. The electric field is stronger at point A compared to the point B. So which is nearer to the charge, which is nearer to the origin. That is why it is more stronger. And let P be the general point is at a distance x from Q. So that is the P. P is in another point considered. Now the electric field at P is given by E is equal to, we know the formula, we have studied this. E is equal to 1 upon 4 pi epsilon naught into Q by x square. So this is the electric field at point P. Now we have applied a force. Applied a force is moving from P to a small distance dx. When I apply a force, what is that force applied? Force is equal to E into Q. So let us substitute for E. So 1 upon 4 pi epsilon naught into Q upon x square into Q. So this is the force applied. And now what is the work done? Work done in moving from point P to a small distance dx. That is the work done. Work done is given by dw is equal to 1 upon. So what is the work done? Work done is force into displacement into cos theta. So what is that force? 1 by 4 pi epsilon naught into q upon x square into q upon x square into dx. What is dx? A small distance, small work done, small distance covered, small distance moved the test charge towards O. So that is small distance. That small distance is dx, and the angle between these two are 180 degree. That is why it is cos 180 degree. Since cos 180 degree is -1, so when I substitute for this, I will get -1 upon 4 pi epsilon naught into q upon q upon x square into dx. So this is the work done. Now, so this is the work done expression. Now what is the total work done? Total work done in moving the test charge or applying the force from B to A. So that is the work done. So total work done is, this is the small work done for, that is for a distance dx. The total work done is the integration of all this. So integration of from B to A, that is the distance moved from RB to RA. Integral of RB to RA is given by 1 upon 4 pi epsilon naught q cubed by x square into dx. So let us take out the common factors, the constant factors outside, and only the integral parameter is 1 upon x square into dx. So 1 upon x square can be rewritten as x to the power of -2. So integral of x to the power of -2 is x to the power of -1 divided by -1. So that is the integration of x to the power of -2 on the limits R A and R B. So when I rewrite this expression x to the power of -1, I will get back 1 by x. So q into q upon 4 pi epsilon naught into 1 by x upon the limits R A and R B. So if I substitute, apply these limits, 1 upon RA minus 1 upon RB. So now work done. So per unit charge, so work done WAB per unit charge is, let us divide it by Q. So if I divide it by Q on both the sides, it will going to be the potential difference, because potential difference is work done upon the charge. So potential difference is equal to WAB by Q. So is equal to, on right side I will get the expression q upon 4 pi epsilon naught into 1 by RA minus 1 by RB. So the potential difference can be rewritten as either V or VA minus VB is equal to q upon 4 pi epsilon naught into 1 upon RA minus RB. So this is the expression for the potential difference related to a source charge. So further, the potential difference at a point, in the, when we modify this expression to the potential at a point, means let us the B, the point B is same as the point A. B is will going to be moved to point A, that is 1 upon RA. So that RB value will going to be 0. When RB value will going to be 0, you will going to have the expression q upon 4 pi epsilon naught in 1 into 1 by RA. That is the modified expression for the potential at a point. So potential at a point. So which is the RB, point B will not exist, only point A will going to exist. So point A will going to exist and the voltage at infinity will going to be 0, since B point may be at infinity. So when B point is at infinity, V infinity will going to be 0. So that is potential is decreasing. So that is why when we consider B at infinity, so the voltage only one point will going to exist, that is at A. So 1 upon 4 pi epsilon naught into 1 by RA minus 1 by RB. So that is all about the potential difference, the topic discussion of the topic potential difference. So in the next class we need to continue with the current and the current density. Thank you.